reports of a long journey, but now the Voyager 2 spacecraft has finally bid farewell to our solar system.
The most distant human-made object in the universe is sending usable information to Earth again.
47 years ago, NASA launched 2 small spacecraft that would rewrite everything we thought we knew about the universe. After traveling over 15 billion miles, Voyager 2 picked up a low, unexplained hum echoing through interstellar space. It hinted at something bigger. Are we trapped in a collapsing cosmic bubble? And have we just tapped into the galaxy's hidden network by accident? Join us as we find out what signal the Voyager 2 just sent back that changes everything. The signal that shattered reality.
NASA could regain control of the lost Voyager 2 probe after a heartbeat signal was picked up.
Something impossible happened in November 2018. Voyager 2, a spacecraft the size of a small car, pierced through what scientists thought was empty space at the edge of our solar system. What it found there changed everything we believed about our place in the universe. The signal came back different, not garbled or weak, different in a way that made NASA engineers stop what they were doing and stare at their screens.
NASA says it has heard from the Voyager 2 spacecraft, which right now is in interstellar space.
After 41 years of faithful service, Voyager 2 had crossed into interstellar space and discovered we're not living in the cosmic neighborhood we thought we were. We're trapped inside a bubble. Not the kind of bubble you blow with soap. This one stretches 11 billion miles across, powered by our sun's constant stream of charged particles called solar wind. Everything you've ever known, Earth, Mars, Jupiter, even the distant Pluto, sits inside this invisible barrier that separates us from the rest of the galaxy. Think of it like living inside a snow globe your entire life, never knowing there's a whole world beyond the glass. Voyager 2 just pressed its face against that glass and saw what's really out there. The moment of crossing felt anticlimactic to most people watching from Earth. No dramatic explosions or cosmic fanfare, just a subtle shift in the data streaming back from a probe 15 billion miles away.
Means that the signal just misses us completely, but we've caught the edge of that signal, so that's the good news.
But scientists knew they were witnessing history. This was only the second time a human-made object had left our solar system's protective embrace. What Voyager 2 found on the other side defied every prediction. The interstellar medium, the space between stars that scientists expected to be cold and empty, turned out to be a furnace. Temperatures reached 54,000 degrees Fahrenheit. That's hot enough to vaporize any metal instantly, yet Voyager 2 survived because this plasma is so thin and spread out that the actual heat barely registers.
In 2018, Voyager 2 boldly ventured into the realm of interstellar space.
But temperature wasn't the shocking part. The shocking part was the pressure. For decades, scientists believed our solar system drifted through space like a ship through calm waters. Voyager 2's instruments revealed we're plowing through interstellar space like a submarine fighting against crushing ocean depths. The interstellar medium pushes back against our sun's protective bubble with 10 times more force than anyone calculated. The implications hit scientists like a freight train. If we're pushing through dense interstellar material with such force, what happens when that material pushes back? Computer models now suggest our sun's protective heliosphere, that 11 billion-mile bubble-keeping cosmic radiation from sterilizing Earth, might be far more fragile than we realized. Voyager 2's plasma instrument, the same device that failed on Voyager 1 back in 1980, captured something even stranger as it crossed the boundary.
The Voyager 2 spacecraft has crossed a boundary that marks the start of interstellar space.
The spacecraft detected streams of particles flowing in both directions across what should have been a solid barrier. Our solar system's edge isn't a wall. It's more like a screen door. Interstellar particles leak in. Solar particles leak out. The boundary between our cosmic neighborhood and the galaxy beyond is porous, dynamic, constantly shifting based on forces we're only beginning to understand. This permeability explains mysteries that had puzzled astronomers for years. Why do we detect particles inside our solar system that originated from distant stars? Why does cosmic radiation fluctuate in patterns that don't match solar activity? Voyager 2 showed us the answer. Our protective bubble breathes. The spacecraft also revealed something unsettling about the shape of our cosmic prison. Based on where Voyager 1 and Voyager 2 crossed into interstellar space, scientists now suspect our heliosphere isn't the neat sphere they'd imagined. It might be stretched into a comet-like tail, with our entire solar system riding inside the head of this cosmic bullet as we hurtle through the galaxy at 290,000 miles per hour. Picture our sun dragging a wake of charged particles behind it, like a speedboat churning through water.
The particles steal energy and speed, like a baseball accelerating off a bat.
Everything we've ever known exists in the turbulent bow wave ahead of this cosmic vessel, protected by forces we're only now learning to measure. But Voyager 2 saved its most haunting discovery for last. Beyond the heliopause, beyond the edge of everything we call home, the spacecraft's instruments detected a persistent hum. Not the chaotic noise of solar eruptions or stellar explosions, but a low, continuous signal that suggests the interstellar medium itself is alive with subtle activity we never suspected. But how did two aging spacecraft manage to escape our cosmic prison at all? What cosmic lottery ticket did NASA cash in to make this impossible journey happen? Racing against a once-in-a-century window.
Voyager 1 and 2, planetary explorers. They are the farthest human-made object sent into space.
The math was brutal. To reach the outer planets with 1970s technology, NASA needed something that happens once every 107 years, a precise alignment of Jupiter, Saturn, Uranus, and Neptune that turns the solar system into a cosmic pinball machine. Without this alignment, getting to Neptune would take 30 years and require a rocket the size of a skyscraper. With it, a spacecraft could bounce from planet to planet like a steel ball ricocheting through a pinball machine, picking up speed with each gravitational encounter. Miss this window, and humanity would wait another century for the next chance. The window opened in 1977. It would slam shut by 1979. Gary Flandreau, a graduate student at Caltech, spotted this opportunity while running trajectory calculations on an early computer. The numbers that appeared on his printout made him double-check his work. 4 giant planets would line up in a configuration that hadn't occurred since Thomas Jefferson was president. The next alignment wouldn't happen until 2064. NASA had exactly 2 years to design, build, and launch the most ambitious exploration mission in human history.
The roll program is in on time. Vehicle response is normal.
The original plan was audacious beyond measure. 4 spacecraft would launch toward the outer planets, with 2 taking the fast track to Jupiter and Saturn, while the other 2 continued to Uranus and Neptune. The mission planners called it the Grand Tour, a sweep of the outer solar system that would revolutionize our understanding of the planets beyond Mars. Congress looked at the price tag and said no. The full Grand Tour would cost nearly $1 billion in 1970s money. Politicians couldn't justify that expense for what seemed like academic curiosity about distant worlds that most Americans couldn't even name. The program was gutted, scaled back to just 2 spacecraft with a primary mission to Jupiter and Saturn. NASA engineers found themselves in an impossible position. They had to build a spacecraft capable of surviving a journey to the edge of the solar system, but they could only get funding for a trip halfway there. Their solution was ingenious. They would design the Voyagers for the full Grand Tour, then publicly commit to only the scaled-back mission. If the spacecraft survived Jupiter and Saturn, NASA could quietly extend the mission to the ice giants. If they didn't, no promises would be broken. It was bureaucratic sleight of hand that would determine whether humanity got one chance to see the outer planets or four. The engineering challenges seemed insurmountable. These spacecraft had to operate flawlessly for decades in an environment that would destroy most electronics in months. Cosmic radiation would gradually fry their circuits. The cold of deep space would freeze their mechanical parts. And they had to do all this while maintaining pinpoint accuracy across billions of miles. The power source alone required revolutionary thinking. Solar panels become useless beyond Mars, where sunlight is 40 times weaker than on Earth. The Voyagers needed a nuclear heartbeat, radioisotope generators.
The region of space outside the boundary produced by wind streaming from the sun.
That would convert the decay of plutonium into electricity for decades. Each spacecraft carried 44 pounds of plutonium dioxide, enough to power a small town, but compact enough to fit in a briefcase. The computers aboard Voyager were less powerful than a modern calculator. They had 68 kilobytes of memory, about enough to store a single digital photo today. Yet these primitive machines had to navigate across interplanetary distances while simultaneously managing dozens of instruments and maintaining communication with Earth. The gravitational slingshot maneuvers required precision that boggled the mind. Jupiter's gravity field is so complex that tiny miscalculations could send a spacecraft tumbling into the planet's crushing atmosphere or spinning off into deep space. The margin for error is measured in minutes of arc, slices of the sky so thin they're nearly impossible to visualize.
From the Voyager 2 spacecraft, which right now is in interstellar space, billions of kilometers away.
Launch day carried its drama. Voyager 2 lifted off first, on August 20th, 1977, even though it would arrive at Jupiter second. The Titan Centaur rocket that carried it into space was notorious for failures. 3 previous launches had ended in explosions. If Voyager 2's rocket failed, there might not be time to prepare another launch.
2, 1, we have ignition and we have liftoff.
Before the planetary alignment shifted out of reach. The rocket performed flawlessly. 16 days later, Voyager 1 followed its twin into space aboard an identical Titan Centaur. Both spacecraft settled into trajectories that would carry them toward Jupiter at 60,000 miles per hour. But the real gamble wasn't technological. It was biological. The engineers building Voyager were betting their entire careers on machines that would outlive them. Most of the scientists who designed the mission's experiments would retire before the spacecraft reached Neptune. Some wouldn't live to see the data their instruments collected at the edge of the solar system. The Voyager team was designing for people who hadn't been born yet. Each spacecraft carried a golden record.
NASA successfully averted a problem. Its engineers had sent a wrong signal to Voyager 2 and had lost contact for nearly about 10 days.
A 12-inch disc containing sounds and images from Earth. The record includes everything from Bach to Chuck Berry, greetings in 55 languages, and sounds ranging from thunder to a baby's cry. It was humanity's message to potential extraterrestrial civilizations, but it also served as a time capsule for future humans who might find these artifacts drifting through interstellar space millions of years from now. The irony wasn't lost on mission planners. They were launching spacecraft that would survive longer than most mountain ranges. Yet, they had no guarantee the civilization that built them would still exist when the Voyagers finally went silent. As both spacecraft raced toward Jupiter, the window that made their journey possible was already closing. The planets were beginning their slow dance away from alignment. By 1979, launching a similar mission would become impossible with existing technology. NASA had seized a once-in-a-century opportunity with machines that had to work perfectly on the first try.
NASA is this morning searching for its Voyager 2 spacecraft.
Across distances where repair was impossible, and mistakes meant losing billions of dollars and decades of preparation. The ultimate gamble was this: betting everything on 1970s technology to unlock secrets that would reshape human understanding of the cosmos. No second chances, no do-overs, just two small spacecraft carrying the hopes of an entire species into the darkness beyond the edge of their world. The gamble paid off beyond anyone's wildest dreams. But what happened when Voyager finally reached the edge of everything we call home? When humanity touched infinity. August 25th, 2012. 15 billion miles from Earth, Voyager 1's instruments detected something that shouldn't exist. The spacecraft had been traveling for 35 years when its plasma wave detector picked up vibrations in the cosmic medium around it. Oscillations that revealed the density of space itself had suddenly jumped to 40 times what it should be. We had crossed a line no human-made object had ever crossed before.
The Voyager twins were launched in 1977, and both are now traversing the Milky Way's interstellar medium.
The boundary wasn't marked by warning signs or cosmic barriers. There was no dramatic moment when stars suddenly looked different or alien landscapes appeared on Voyager's cameras. The crossing happened in the most mundane way possible, through subtle changes in electrical readings that took scientists months to decode. But those electrical readings revealed something extraordinary. Voyager 1 had pierced the heliopause, the invisible shell that separates our solar system from the rest of the galaxy. For the first time in human history, we were touching interstellar space. The discovery almost didn't happen. Voyager 1's plasma instrument had failed back in 1980, leaving scientists partially blind to the very measurements they needed to confirm the crossing. They had to get creative, using the spacecraft's plasma wave detector to listen for the cosmic equivalent of sonar pings. When the sun erupted in massive solar storms between April and May of 2013, those eruptions sent shockwaves racing outward through space. Voyager 1's instruments detected these shockwaves hitting nearby electrons, causing them to vibrate like struck tuning forks. The frequency of those vibrations told scientists exactly how dense the surrounding space had become. The numbers were staggering. Interstellar space contained 40 times more particles than the region Voyager had just left behind. We weren't floating in the cosmic equivalent of a calm lake. We were swimming in an ocean of charged particles that had been invisible until Voyager pushed through the barrier, keeping them out. 6 years later, Voyager 2 would make the same crossing with a crucial difference. Its plasma instrument still worked perfectly. When the second spacecraft pierced the heliopause in November 2018, it sent back data that confirmed what Voyager 1 had discovered and revealed new mysteries that left scientists scrambling to rewrite textbooks.
Plasma density and magnetic particles upon crossing the heliopause.
The boundary between our solar system and interstellar space wasn't the solid wall anyone expected. Voyager 2's instruments showed particles flowing in both directions across what should have been an impermeable barrier. Solar wind leaked out, while interstellar particles leaked in, creating a dynamic interface that breathed like a living membrane. The temperature readings defied all predictions. Interstellar space registered temperatures hot enough to vaporize any known metal instantly. Yet both Voyagers survived because this hellish heat was spread so thin across vast distances that the actual thermal energy barely registered on their instruments. We were flying through a furnace that felt cold to the touch. The magnetic field measurements revealed another shock. Scientists expected the interstellar magnetic field to align roughly with the direction of our solar system's movement through the galaxy, like wind patterns around a moving car. Instead, Voyager 1 found a magnetic field running perpendicular to our motion, sideways to everything we thought we understood about our cosmic neighborhood. Voyager 2's magnetic readings were completely different. The second spacecraft encountered field lines that seemed to twist and spiral in patterns that suggested vast currents flowing through interstellar space on scales we could barely comprehend. Either our instruments were malfunctioning, or the space between stars was far more complex and dynamic than we had ever imagined. The data forced scientists to confront an uncomfortable truth.
Space is, even in our galaxy, it's mostly empty space. When our two galaxies collide, almost no stars will hit any other star.
We knew almost nothing about the cosmic ocean we were swimming through. Our solar system wasn't drifting peacefully through space. It was bulldozing through a medium dense enough to push back with tremendous force. Both spacecraft detected something else that changed everything. A persistent background hum in the interstellar medium. Not the chaotic noise of stellar explosions or solar eruptions, but a steady, low-frequency signal that suggested the space between stars hummed with subtle activity we had never suspected. This cosmic background hum varied in intensity and frequency in ways that hinted at structures and currents flowing through interstellar space on distances that dwarfed our solar system. We weren't just floating in empty darkness. We were floating in an ocean of plasma that connected every star in the galaxy in ways we were only beginning to glimpse. The crossing revealed the true nature of our cosmic prison. The heliosphere that protects us from galactic radiation isn't a static bubble. It's a dynamic structure that expands and contracts based on solar activity and interstellar pressure. When the sun is active, our protective bubble grows larger. When solar activity dims, the bubble shrinks, potentially exposing the inner planets to radiation levels that could sterilize entire worlds. The spacecraft also discovered that the heliopause itself moves. The boundary between our solar system and interstellar space shifts position based on the pressure of the interstellar wind hitting us from outside.
The second time in history that a human-made object has escaped our solar system.
We're not sitting still in a fixed location. We're riding inside a bubble that moves and changes shape as our entire solar system plows through the galaxy at 67,000 miles per hour. The most unsettling discovery was how little we understood about our place in the cosmos. The data from both Voyagers came from just 2 points along the vast boundary of our solar system. We were trying to understand the shape and nature of a bubble 11 billion miles across using measurements from 2 tiny pinpricks. It was like trying to understand the ocean by sticking 2 thermometers into the surf. The crossing changed everything because it revealed how much we didn't know. We discovered that our solar system exists inside a larger structure called the local bubble, a cavity in interstellar space spanning 1,000 light-years across. We found ourselves positioned near the center of this cosmic hollow, like explorers who suddenly realized they'd been living inside a vast cave their entire lives without knowing walls surrounded them.
We knew they were all gas giants, mostly made up of hydrogen and helium and some methane on the outer planets.
Voyager 1 and 2 had touched infinity and discovered we were still trapped inside something even larger than we could measure. But the most shocking revelations were yet to come. What did these signals from the cosmic abyss reveal about reality itself? Revelations from the abyss. The signals that changed everything weren't dramatic bursts of alien communication or cosmic explosions. They were subtle variations in a background hum that Voyager 1 detected drifting through interstellar space, a persistent drone that revealed the universe operates nothing like we thought. This interstellar hum varies in ways that suggest massive structures flowing through the space between stars.
Voyager takes the cake. It's the most audacious mission. I mean, who'd have thought that we'd actually be able to do that?
We're not floating in cosmic emptiness. We're swimming in an ocean of plasma that connects every star in the galaxy through currents and streams we never knew existed. The discovery forced scientists to confront an uncomfortable truth about our cosmic address.
Our solar system to the higher plasma density in the interstellar medium.
Our entire solar system sits inside the local bubble. We are positioned remarkably close to the center of this cosmic void, like finding ourselves in the eye of a hurricane we never realized was there. This placement isn't random. The local bubble formed when multiple massive stars exploded as supernovas millions of years ago, blasting out a cavity in the dense interstellar medium. We're living inside the blast zone of ancient stellar explosions that cleared out our cosmic neighborhood long before Earth even existed. The walls of this bubble are made of compressed gas and dust, the debris from those long-dead stars now forming a shell around us. Outside this protective cavity, interstellar space is far denser and more chaotic. Inside, we enjoy a relatively calm pocket of space that may have been crucial for life to develop on Earth. But Voyager's data revealed something even more unsettling. The bubble that protects us is shrinking. The interstellar wind, streams of particles flowing between stars, pushes against our local bubble with enough force to compress it over time.
Which is the region of gas and radiation that makes up the space in between star systems.
Computer models suggest this protective cavity could collapse within the next few million years, exposing our solar system to radiation levels that would make interstellar travel impossible and potentially threaten life on Earth. We're living on borrowed time inside a cosmic safe house that's slowly being crushed by forces beyond our control. The spacecraft also detected something that rewrote our understanding of how galaxies work. The magnetic field measurements from both Voyagers revealed that interstellar space is crisscrossed with invisible highways, magnetic field lines that channel particles and energy across vast distances. These cosmic highways connect star systems in ways we never suspected. Matter and energy flow along these magnetic pathways like traffic on an interstate system, linking the birth and death of stars across the entire galaxy. Our solar system isn't an isolated island floating in space. It's connected to every other star through a web of magnetic connections we're only beginning to map. The temperature readings from both spacecraft shattered another fundamental assumption. The space between stars isn't the cold, empty void we imagined. It's a seething ocean of plasma, heated to temperatures that would vaporize any planet instantly, yet spread so thin that the actual heat barely registers. We discovered we're flying through a cosmic furnace that feels cold to the touch, a contradiction that challenges everything we thought we knew about the physics of space. Perhaps most remarkably, both Voyagers detected particles that originated from other star systems. These alien particles are streaming past Earth right now, carrying information about distant worlds and stellar processes happening hundreds of light years away. We're constantly bathed in matter from across the galaxy without ever knowing it. The revelation gets stranger. The boundary between our solar system and interstellar space isn't fixed. It moves based on solar activity and interstellar pressure. When our sun is active, it pushes the boundary outward. When solar activity dims, the boundary shrinks inward, potentially exposing the inner planets to deadly galactic radiation. We live inside a breathing bubble that expands and contracts based on forces we barely understand.
Stellar space where the plasma is much denser than it is inside the bubble around the sun.
The data from both spacecraft forced scientists to abandon their neat models of how space works. Instead of empty vacuum punctuated by occasional stars, we discovered a dynamic, interconnected medium where everything influences everything else across distances that boggle the mind. The signals from deep space revealed that our universe operates more like a living organism than a mechanical system. Stars breathe, space flows, magnetic fields pulse with energy that connects distant worlds. The cosmos isn't a collection of isolated objects floating in nothingness. It's a single, vast, interconnected system where every star influences every other star through forces we're only now learning to detect. Voyager 1 and 2 didn't just escape our solar system.
The Voyager 2 spacecraft has crossed a boundary that marks the start of interstellar space.
They revealed that our solar system was never separate from the rest of the universe in the first place. We're part of something so large and complex that 47 years of exploration have barely scratched the surface of understanding what we're actually embedded within. But these discoveries pale compared to what lies ahead. Where will these immortal machines venture over the next billion years? The eternal journey. In October 2024, something extraordinary happened that proved these spacecraft are far from finished with their revelations. Voyager 1's primary communication system suddenly went silent, leaving NASA engineers staring at their screens in disbelief. The spacecraft was over 15 billion miles away.
NASA says that Voyager 1 has become the first man-made object to reach interstellar space, the cold, dark region between stars.
So distant that radio signals take 22 hours to reach it. Then, from the cosmic darkness, came a faint whisper. Voyager 1 had automatically switched to a backup transmitter that hadn't been used since 1981. This ancient radio system, dormant for 43 years, flickered back to life when the spacecraft's fault protection software detected the primary system failing. The machine was taking care of itself at the edge of known space. The backup transmitter is weaker and provides less detailed data, but it proved something remarkable. These spacecraft possess a form of technological immortality that their creators never fully grasped. They were built with redundancies within redundancies, designed to survive scenarios that wouldn't occur for decades after launch. The engineers who designed these backup systems in the 1970s were essentially communicating with the future, embedding solutions for problems that wouldn't manifest until most of them had retired or died. It's the closest thing to technological resurrection we've ever achieved. In 1 billion years, when both spacecraft have traveled 50,000 light-years from the Sun, these golden records might be the only remaining evidence that humanity ever existed. The trajectory calculations reveal something almost poetic about their eternal journey. Voyager 1 is heading toward AC plus 793888, a faint star in the constellation Camelopardalis. It will reach the vicinity of this distant sun in about 40,000 years, though by then the star itself will have moved, and the encounter will be a ghostly pas de deux between ancient light and human ambition. Voyager 2 follows a different path toward Ross 248, a red dwarf star in the constellation Andromeda. This spacecraft will make its closest approach to another stellar system in roughly 40,000 years as well, carrying its golden record past worlds we can't even detect from Earth. But the most remarkable revelation about their future came from recent computer models that tracked their paths across cosmic time. These simulations revealed that both Voyagers will eventually orbit the center of our galaxy, becoming permanent residents of the Milky Way's vast spiral arms. They'll witness the birth and death of countless stars over the next few billion years. They'll drift through stellar nurseries where new suns ignite from collapsing gas clouds. They'll coast past dying giants that explode as supernovas, scattering heavy elements across interstellar space. They'll see the galaxy itself evolve and change in ways we can barely comprehend. The spacecraft that started as 5-year missions to Jupiter and Saturn have become humanity's first attempt at true immortality. Not biological immortality, but the kind that transcends individual lifespans and carries the essence of a civilization across cosmic time. Recent analysis of Voyager data
It actually happened last year, but NASA only confirmed the data on Thursday.
Has revealed something that changes how we think about interstellar exploration itself. The persistent background hum both spacecraft detected in interstellar space varies in patterns that suggest this cosmic medium carries information across vast distances. The space between stars might function like a galaxy-wide communication network, transmitting data about stellar processes and cosmic events across hundreds of light years. We accidentally launched our spacecraft into what might be the universe's own internet. The implications are staggering. If interstellar space can carry information between star systems, then advanced civilizations might be communicating through methods we've never considered. The Voyagers might be swimming through conversations between alien intelligences that span distances we can barely measure. Both spacecraft continue to transmit data back to Earth, though their power supplies, radioisotope, thermoelectric generators, are gradually fading. Engineers have already begun shutting down non-essential instruments to conserve energy. Their nuclear cores may sustain basic operations for less than a decade before the freezing silence of space shuts them down completely. Yet even after their signals stop, Voyager 1 and Voyager 2 will drift onward through the stars, silent and alone, as humanity's most distant and perhaps most enduring messengers to the cosmos. They've already accomplished something no human will ever do. They've left the influence of our sun forever. While we remain bound to our star by gravity and solar wind, the Voyagers have broken free to become citizens of the galaxy itself. In a universe where most things are temporary, we built something eternal. 2 small machines that will carry the story of humanity through space long after our species is forgotten. Thank you for watching. Like, comment, and subscribe. Also, check out another interesting video by clicking on the video shown on your screen. See you on the other side.